Welcome to another episode of the Some Engineering Podcast. Today, very exciting guest, Yevgeny Pats, founder and CEO of CloudQuery. Hey, Yevgeny, really excited to have you on.
Hey, Lars. Thanks for having me. Really excited to be here.
So we prepped quite a bit for this call, and lots of topics to talk about: ELT, infrastructure data. But let's start with what does CloudQuery do? What problems do you solve? And maybe talk a little bit about the genesis of the company.
Yeah, sounds great. So CloudQuery started as an open source project. We are at the very basic, at the very root of that, we are an ELT framework, open source ELT framework. So basically helping move data from one source to another destination. So that's the really high level description of what we do, and we can go deeper in what is a framework and what is an ELT framework. Mm-hmm. It's really started as an open source project exactly 2 years ago, a bit more, even before we raised our seed round. And it's really, we started just as solving one use case actually, unrelated to ELT, because we didn't understand, or I didn't understand at the time that actually it is we are going to build an ELT framework. So I just wanted to get data out of AWS APIs to a Postgres database, so I can analyze it there instead of having DSLs or analyzing it in Python and memory. I just wanted to have it in Postgres, and that's basically it. And this also was the first version, and people, seem to like it, so we doubled down on that. But as we move forward, people asked for, okay, maybe can you do me another database, or can you do another source? And we are like, wait, but if we build it, so actually the problem that we are solving is not moving data from AWS to Postgres. We are actually solving the problem of how do you move data from any source to any destination.
Mm-hmm. So then, and that's what turned you into an overall ELT framework, like any source and any destination. Before we go into that, can you double click a little bit about getting or extracting AWS data? Like what data specifically are we talking about?
Yeah, so AWS. So we started with AWS because also I'm coming from the cloud world and the cloud security world, and AWS in particular is an interesting use case and a complex one, because AWS has more than 1,000 APIs, and growing every year. And the data is more of a metadata, is things like it's not your data from your database. It's just simple things like how many machines you have, what are their configuration, how many buckets you have, how many users you have, what is their configuration. So it's a lot of metadata about the infrastructure configuration itself rather than the data inside. So it's really the configuration metadata. And there is, the funny thing is that you said, oh, there is probably not a lot of it. There is a lot of it. Especially in big AWS account, there is a lot of it, and there is no one single API where you can say, okay, get me give me all that. It's a lot of APIs. Sometimes they're not consistent, and because of that, it this problem on itself is a big challenge to a lot of companies. If they want to do some kind of analysis or anything, they have to always write this on their own, get again and again to get their specific use case. So there is so we started by trying to generalize it better, right? Transform all that information to a database where the data is structured, and then you have a query language where you can query, and people can do whatever they want, because I can't know ahead of time what folks want to do with the data. So the best we can do is just normalize it to to a database. That's basically the underlying solution.
So many questions that I think we need to dive into. Let's stay a little bit in the what, and then let's move into the why. Why would people want to have this type of data? So you said, I think this is an important distinction. People get this not always right. Like, you're not collecting records from a database like a Postgres or like an RDS, Amazon RDS, or an Amazon Aurora, right? You would collect the metadata off that database, like how is it configured, how many nodes does it have, whatever, that's what you collect, correct?
Yeah, exactly. Yeah, that's important. Like we can't get all the data from all databases to one database. That's like a bit different problem, and probably you don't really like it's a different problem, and we can discuss it as well. But yeah, it's just the like you said, how it is configured, like how many backups per day it is doing, what versions those RDS are running, when they started to run, when they were created, when their last backup happened. Like there are so many, if you ever try to configure Terraform, right, or Pulumi, when you write the Terraform, right, then you have so many properties to configure. So those are, all the properties that you can. This is how you create the infrastructure. So basically, that metadata about the infrastructure.
Yeah, and so essentially, you call the same APIs to extract data that a Terraform or a Pulumi or any infrastructure of code tool would use to deploy those same resources. Would that be correct?
Yeah, just kind of the other way around. Like they usually do the create APIs and maybe make get, and we are like using a lot of the like list APIs, like get, everything that is there, and like transform, and we are doing like the transformation and then sending to destination, where Terraform and Pulumi just do the create and then transform it only like to internal structure just to know what was configured. So they're like solving a specific, like a big use case, but the specific one of provisioning rather than kind of ELT or inventorying.
Right. And you said there's over 1,000 APIs, and the complexity here is like AWS has all these different product heaps, and not just AWS, right? GCP and Azure as well, maybe just at a smaller scale, but they don't talk to each other, right? They don't in the sense of they don't align on the data they expose via their APIs, right? There's no single AWS API that allows me to get this data, correct?
Unfortunately, no.
Yeah.
And in GCP and Azure, exactly like you said, like when we talked about AWS, which is a big like challenge, how do you like understand what you have, analyze and do anything at scale. The same, it only grows if you have GCP, and sometimes like some companies have like both. Like maybe one is more used, but you still have some footprint in GCP and Azure, which is very similar challenge with the APIs and metadata.
So you solved that problem. You've built with CloudQuery, you've built a framework that helps me extract this data, run the jobs right on whatever cadence I want. It's normalized. You flatten it out, usually into tables. I think you also support a few other destinations like graph databases. We can talk about that. Now, can you share a little bit about? You said like, okay, you started by, hey, I want this AWS data. We open sourced it, and then other people said, I want this data too. What is the why? Can you talk about why people would want this data?
Yeah. So I think because we started with AWS use cases, then we saw a lot of, it's kind of a bias depending on what you build, like on what you build. So because we started with AWS data, then we saw a lot of use cases around around security, around cost, around governance. So like platform teams trying to understand, okay, how many disks unattached to anything I have, which I need to delete, or how many like projects I have with too many like untagged instances, or like there is like infinite number of things basically that you want to know depending on or the organization or the use cases. And this is why basically you want like a query engine that you can query like any of those use cases, right? And you want the data in a database. Like it's kind of like the best way to solve it in a generic way. So yeah, so we saw a lot of like governance, cost, security, where platform teams like install it and use it themselves, but also we saw like secure like the platform or the DevOps engineers, right, run it, put the data, and then they kind of like tell, okay, now we make sure we are running it, that it runs on a daily basis, that it works, that the machines are running, that are doing the extraction, and the database is working, and then the security team has access to that data, so they can work on their problems and solve their solve their tasks, and the governance team can do their work with the same data, and kind of like everyone can work nicely with the same data without like running again the same transformation, the same like workloads, which is like also work like to make sure that the data pipeline is kind of running.
Mm-hmm. Yeah, and this sounds very, very similar to classic analytics and data lakes and the way we've seen it in analytics engineering in the past 5 to 6 years. I'll before we go into this topic of data lakes and ELT, you mentioned that these teams wanted to have this data to solve governance, security, and cost use cases, and we all know there's no shortage of operational tools, right? DevOps, SecOps, FinOps tools out there that acquire this type of data and give you an opinionated view on it, right? And so now, why do you think would all of a sudden these people now say? I mean, I think I know why. We all know why, but like, let's elaborate a little bit on why would people want this raw data versus using a tool? What's the delta between those two paradigms?
Yeah, so I think it's just a classic industry transformation, and I think it's the same thing that happened also in the marketing. So it's kind of like, actually it happens in a lot of areas. It's kind of it's the bundling and unbundling of things. It's I think related to that, but when 10 years ago like AWS started, or maybe even more now, like I don't recall the exact, but they started like with S3 APIs and compute. A year later, maybe they had like 10 more APIs, right? And then like if you have like a one tool that, so like basically when you have 5 APIs, if you're a vendor, that you kind of can come up with all the permutations of the use cases. You can say, okay, like I know all the queries ahead of time. So it's like the permissions on the S3, like number of S3, I can like build a dashboard. Like I can already build the dashboard for you because I just know all the permutations, right? Mm-hmm. And I can build it for you. Mm-hmm. But then when the number of APIs grows, then it kind of stops working. The vendor can't actually already come up with all the permutations. There are too many. You can't come up with all the queries, and you can't even maintain all the APIs anymore of the extraction. This is another challenge, and kind of like then you need, like, as the user, you need to look for another solution, which is like you want to get the data, and then you have to, like, you yourself, the user, need to define the queries and the analysis in the dashboard, because the vendor, they can't know what you need ahead of time. You can have examples, but I can't build dashboards for all the companies in the world. I have to give users, like, I can give them a head start. This is like an example, but then the users need to have like access to the raw data to customize it.
Mm-hmm. So this is almost like the why for CloudQuery, because everyone needs to have this data. Now we have a growing set of APIs. It becomes more and more complex. And so at some point, everyone does the same famously called undifferentiated heavy lifting. There's no point, right? That has created the need for a horizontal layer. And that horizontal layer would be CloudQuery in this case.
Yeah, exactly. We will be focused on the, like, if you talk about the modern data stack, right, will be the ingestion layer. So we ingest we are solely focused on uh, making sure we have all the APIs covered for the plugins that we maintain, giving users the ability to contribute to those plugins back, because like there are a lot of those APIs, building the framework and giving users an easy way to build more plugins on top of CloudQuery, because we can't maintain all the APIs. So we're really like, it's kind of the unbundling. We are solely focused on the ingestion layer. And then once it is in the database, then you can use like different other solutions which are focused on whether it's transformations, things like dbt, whether it's visualization, like things like Grafana or Superset, because it's just two different problems which are like, each of them is big enough, right? We can't, like, inside CloudQuery we can't really develop Grafana and then like and CloudQuery, like we are already working hard, so it will be too hard to develop also a Grafana.
Yeah, you got your hands full collecting data. And we had Julia from DBT on. We talked a lot about the modern data stack. And I think that's a very interesting aspect, because so the modern data stack has developed over the last, let's say, 4 to 5, 6 years, right? And we kind of all know the vendors, the prominent vendors in that. You mentioned DBT. We had Julia on the podcast. In my experience, so what may be super familiar for classic data engineers and analytics engineers who work with marketing and sales data, we haven't seen that as much yet working with infrastructure data. And in the concept of infrastructure data in the modern data stack, have you seen that there's a change, or like what change have you observed? Are people realizing this concept can be applied to infrastructure data?
Yeah, I think it's like in progress. I think it's like not everybody realize it yet, but I think like people start to realize that it's just like this is the technical solution. So eventually, if there is a problem and there is like one kind of technical solution to that, I think everyone will eventually come to the same conclusion. But yeah, I think like it took time because it is something new in the infrastructure space, because because the cloud is like much newer than cloud APIs are newer than Google Analytics APIs. Like Google Analytics was before that, so it just takes time. So yeah, like people are now security engineer, platform engineers are like, okay, we have to learn SQL or run, like see how ELT, how data tools work, like learn about modern data stack, because it's kind of the best like kind of the best solution to solve a lot of the issues.
Yeah, SQL is simple. Everyone knows it. Everyone knows it, but doesn't necessarily know it well. But that's a different that's a different problem. But it gives you all this flexibility, right? And so do you have a few? Let's just call it an app, right? Even though it's a SQL statement. But do you have some examples for use cases, like little apps that your customers or users have built by using CloudQuery data?
Yeah, sure. I can also share screen if
Please,
you want. Yeah.
please.
Okay. Let me. So, second. All right. So I can so I can go like from the demo and like from the some of the examples that we have, and then I can do just like a short or actually, you know what, let's let me do a quick really quick demo just to
Let's do it.
Yeah, just to explain. So let's start with maybe just the homepage. Yeah, so CloudQuery is open source project. It's all written in Go. So it is like a single binary, and every plugin is a single binary. So it's quite easy to deploy. Like Go solves a lot of problems, so it's easy to deploy. You can run data pipelines without Docker in Docker. You just run it wherever you want.
Mhm.
So let's let me show an example. So you can install like CloudQuery with like brew install CloudQuery.
Mhm.
It's also written on the website. And CloudQuery needs configuration.
Mhm.
So basically, you need to define source or number of sources,
Mhm.
and you need to define destinations.
Mhm.
So it's YAML configuration, kind of like the simplest thing that you can have. You define the version of the plugin. So let's say CloudQuery AWS. You define the tables that you want to sync and the destination.
Mhm.
And for the destination, you can define the destination. So in that case, we use Postgres, and we use like a connection string. So right now, I have a Docker running.
Mhm.
Oh, actually, I don't have. So let's. I do have. So I have a Docker running locally.
Mhm.
So let's run CloudQuery sync. Right now, I'm syncing just like EC2 instances from my Playground account,
Mhm.
so it won't take too long. We'll sync like one resource. So let's wait for a second.
Right. So this is in the background now. You're calling the APIs. You're waiting for the data to get returned, right? And then you sync it to your Postgres instance.
Yeah, exactly. We like in really high level. Yeah, we get all the APIs. We transform it to CloudQuery type system, and then the CloudQuery type system transform it to the destination depending on which destination you
Mhm.
want. So this is why, like, for example, if we maintain a AWS plugin, or if someone wrote a CloudQuery source plugin for whatever API they have, when we add another destination, or when we update a destination, you don't need to do any changes of you don't need to do any changes to the source plugin, right? It will just work. So let's say tomorrow we add a new database, you just use the same source plugin and you add that destination, and it will work because everything, like the source plugin, transform it to a type system, to a CloudQuery type system.
Mhm. Mhm.
So yeah, let's do real quick run a few queries. So this is like Postgres, so I'm
Mhm.
just using like the local pSQL shell, but you can connect it from pgadmin, and from some nicer tools like like Superset, like Grafana, or like Metabase, like
Mhm.
whatever you use, honestly. So let's 1 second. Yeah. Okay. So so I have like one instance returned here, but let's maybe just because it's not quite like you can choose like a specific column, right? So I have like this EC2 instance, and I can query like specific columns, or
Mhm.
like search by specific properties. I can join it with any other data, and like let's maybe do something a bit more exciting.
Mhm.
So for example, we have an example. So we have an example here for a view that we created. And again, it's just
By the way, if sorry, just to interrupt you real quick,
yeah,
were you? So I do see your and this is for the video editor here.
yeah.
I see GitHub, but I didn't see you doing the
Oh,
syncing.
you did it. Oh, okay. So maybe let's do that part again, because I thought I'm sharing the.
Yeah,
Okay.
and I thought it had to do with the fact that you're frozen, so I didn't want to interject. So we can just,
Oh,
if you're cool,
yeah,
we can go back. We can
yeah.
just restart.
Let's do it. Yeah. So let's let me See.
Sorry.
Yeah. No worries. No worries. Maybe it was because it's frozen. Okay, strange. So right now, can you see that? Can you see my terminal?
I can see your entire screen. I cannot see the terminal. I see Riverside.
Oh. And now you can see GitHub, but you can't see.
I see GitHub. Yeah.
But got it. Okay. So I think I understand what's happening. And now can you see my terminal?
Nope. Still can't see it.
Interesting. Okay. Let me try another thing. Sorry. And can you see my terminal now?
Yes, I can.
Okay, great. So, all right. Yeah. So let's do a short demo now of CloudQuery.
Okay, great. So we saw the GitHub repo. Now we're looking at your terminal.
Yeah. So as I said, like CloudQuery is a single binary. You can install it like with brew or wget, and CloudQuery will download the plugins, which are also like single binary written in Go. So to configure CloudQuery, you need to specify which sources you want and which destination. So here, in that case, we want to sync from from AWS source, and like the example configuration, you can find it on our docs. So basically, it's really like a copy paste. In that case, we are syncing from an AWS plugin with a specific version, and we're syncing like AWS EC2 instances to a Postgres destination, and we configure like the Postgres destination here also to like a specific destination, specific version, and the connection string. And now we can run CloudQuery sync, so it will take all the configuration in the current directory, and I can like also specify specific files, and it will start syncing from my AWS Playground account to my local Postgres instance that is running inside a Docker. So yeah, I think like just AWS EC2 instances because I didn't want it to take a while. And now like let's go and just run a few queries inside our Postgres. I'm going just to use the pSQL shell just for brevity, but basically you can use any any nice tool like Reset or like Superset, Grafana, Metabase, anything like you use to run queries in a nicer way, and also like share them with other team members. But like let's run get all EC2 instances. So like we get all the data about the EC2 instance and all the columns. It is like quite hard to read. So let's like in the terminal. So let's like just ask about the specific like ARN. Okay, so I can see like all ARNs of EC2 instances, and I have all the other data from my EC2. So I can also join like with other data. For example, get me all EC2 instances. Like one I can do like tags, for example. Let's see. Do I have like tags here? Yeah, I have tags, right? So I can query. So I can query like where tags, like where tags are something, right? Or I can join, where tags contains a user that is in the user table, or like do whatever basically I want to do because all the data is here. But let's do something maybe a bit more exciting. So we have a view, like an example view that we created here. So you can see my you still can see my terminal, right?
I see your terminal. Yes,
I see. So on our website, we have a view that we like created that creates like one view that contains all the resources, right? So you can run it just like the same way with pSQL. The view, like I copy pasted here, like create view.sql. The like I can show it real quick, but honestly, just go through the tables and creates a view with like ARN and ID. So what we can do now, we can normalize, all our resources relatively easily just with one view, like one SQL query. So let's do like AWS resources, right? And now we can see the ARN like tags and account ID of all resources. So for example, let's do like, something that we can see more easily, like region tags. Right. So account ID. All right. So this is like a bit more interesting, right? Like AWS resources API doesn't exist in AWS, but we were able like to build really easy a view, a new table that gets the data from all other tables and normalize it to something that, for example, we want, right? To see all resources, their ARNs, their account ID, and I can like visualize this now pretty easily because I don't have like to deal with 600 tables, right? So that's So I think that's like an example, right? And I don't have a Grafana instance installed here, but you can like go to our website as well, right? And see like there are some example like Grafana dashboards that you can customize that are built with those views.
Yeah. So I think so this is a fascinating example because I think you showed a few things, or you showed a single thing, which is a terminal. And as a developer, I can use my credentials to log into our AWS instance. I get all the data. I can install a Postgres instance locally on my laptop, and I can start now extracting data, and I write my SQL queries locally. And everything is open source, right? Obviously, except for the infrastructure. But I mean that like we've done this now for what, like 5 minutes, and you showed me and that 5 minutes covered getting data, setting up CloudQuery, creating a view, and just generating insights, right? So this is a massive shift from maybe drag and drop tools, where as a developer, I'm fully empowered now to get this data.
Yeah, exactly. I think it's really like at the end, it's the right, I think, tool for the job, right? It's a data problem, like on the fundamental level, it's a data problem, and if you use like the right tools, which are like databases and data is a hard thing. How you store it, how you query it, and people were working on that for a long for 40 years. So this is kind of like the best way that you can store data, right? And you don't need to like use Postgres specifically, right? You can use SQLite. So you will just configure a SQLite destination in a similar way, and use SQLite if you want to do just like local things, or and we can like talk about that as well, like configure an S3 destination, right? And use like a more data lake approach, right? Query it.
Before we do that, and I do want to get to the data lake, what type of knowledge do I need to have about the underlying schema and the data I get back from the API? Like, how much of an expert do I need to be for those individual APIs?
So all our tables are documented. Maybe let me share another tab here. So all right. So all our tables are documented in our documentation. So like you have all the tables. So depending on what you want to query, you actually can see also all the columns and their type. So yeah, and you have like also the original API that you can query. So that's the original data, and like what we try to do, right? We basically try to like keep the API and the tables as close to each other, so you have all the data, and then you can do additional transformations as you want.
And this is where the modern data stack comes in. And I can still be, as the infrastructure engineer, I can still be the expert in the type of data we extract. But for users downstream, I can build transformations and remove some of that complexity. And basically, it's almost like a metrics layer for infrastructure. I give you exactly what you want, and that's the only thing you need to understand about this whole thing.
Yeah, yeah, exactly.
Mm-hmm. Okay, awesome. So, geez, we have covered a lot of ground. What's missing? I think data lakes is really interesting. I do want to talk a little bit more about different data sources you started pulling in from SaaS sources, how that came about, and then maybe overall, let's shift then to CloudQuery as a framework. Like, what's the future of the company? I don't know. Where do you want to start? Do you want to go into data lakes first?
Yeah, we can talk about. So yeah, we also like we started with AWS, but I can share my screen again real quick, right? But we have now more than like 20 source plugins, including things like GitLab, GitHub, Launch Directly, PagerDuty, and we also have like a growing set of partners that they maintain their own plugins, right? Like Scaleway, Simple Analytics, Yandex Cloud. So yeah, so it's really like it's really any other infrastructure or analytics APIs as well that you want to bring to the database, right? To the same format and store the data there.
Yeah, and so there's some SaaS tools in there, pretty engineering centric, I would say, still. But where by no means a limitation, right? But in my head, fast forward 3 to 4 years, I feel like we may almost converge. Like, look, there's an existing world of ELT tools, right? And they have their market, CloudQuery you have your market, but how do you see that evolving? And maybe that's the framework aspect. Like, what do you see happening how do you see the future of CloudQuery in that world? Because there's other tools that may be doing some of this already.
Yeah, for sure. There are a lot of tools in the ELD space, and I think it will like definitely converge. Like it's really hard to predict, right? Because there are just so many parameters to be able to predict it. But yes, I think it's going to converge because it's the same underlying problem, and I think part of that, like part of the problems is still like we have a lot of issues around like data interoperability, and we have issues like how do we maintain so many connectors, what is their format, what is the framework that people use, like how one vendor will maintain all connectors in the world, and it's a lot of like also technical and business challenges, and I think they will eventually like be solved because the industry is moving forward. And I think part of it, one, on the connector side, I think vendors, also a lot of vendors, like we already see it even in our partners, will be maintaining their own connectors. So for example, because business incentives are aligned there. So for example, if you're like even AWS, but like even Stripe, you want to enable your users to sync data to any other destination or daily because it's a big use case, right? And if you don't have it, like you either need to implement it yourself, like the whole data pipeline and connection to all databases, or you just implement a source plugin to, like, doesn't matter if it's CloudQuery or any other like ELT framework, and it's kind of similar, like really similar how vendors maintain Terraform provider, right?
Mm-hmm.
So they don't engineer their own Terraform, like they maintain just the Terraform source plugin, and then users can provision, with that. So I think vendors will eventually maintain their own source plugin to ELT vendors. I think that's on the on the business side. I think where things will evolve, and then there are like still some technologies I think around data that are evolving. That I think will help. It will help ELT vendors solve a lot of those issues.
Mm-hmm. That was our doorbell. Sorry.
Yeah, no worries.
Okay. And so, and maybe one thing we haven't really talked about yet is how CloudQuery is implemented. You chose Go as your language, correct?
Yes.
Can you talk a little bit? Let's dive a little bit. Let's go back down into the stack and talk a little bit about your technology choices. And you talked about sources and destinations. Like, can you talk about some of the choices you've made? And let's start maybe with Go. Why Go?
Yeah. So Go solves a lot of problems in around deployments and like operational operational issues, right? So Go, you don't have a runtime, you can run it easily without any Docker on ECS, on EKS. It's more performant for concurrency as well, like in a lot of places. So it was kind of a natural choice when you're working with data, and especially if you want it to be deployed in a lot of places, right? So because we are not a backend, we don't have UI or something, but it is just something that you can deploy and scale. So Go was a natural thing that, okay, we want it to be easily deployable and scalable. So this is one thing. And then I can go into how the architecture in high level.
Yeah. So people love architecture on the show. I can guarantee you that.
Yeah. So let's maybe let me see if I have one diagram. We have one diagram in our website. It can also help. 1 second. All right. So yeah, it's really high level architecture, but I think it makes the point. So basically, we have external APIs, and then we have the CloudQuery source plugins that they get the data from the APIs. They use those source plugins are using CloudQuery SDK, which helps you as a developer to define the schema, transform the data to a CloudQuery type system, and then all this data is sent via gRPC to CloudQuery CLI, right? And the gRPC part here is important. It has to be basically gRPC or some kind of network protocol, because we can't bake in all the source plugins in the world to CloudQuery CLI, right? So we want to give developers the ability to, or users the ability to, write their own CloudQuery plugin and download a community plugin and still use it, right? So CloudQuery plugins are basically like small servers running locally. They're sending the data to CloudQuery CLI, which then in turn is basically just a small proxy, and it sends the data to a destination plugin, which is also a server, because we can bake all destination plugins to the CLI, and then the destination plugin is doing the other way around, kind of taking CloudQuery data, which is transformed to CloudQuery type systems. So we know how to transform every type of that data to destination, right? So because it's already transformed, and it's a strongly typed CloudQuery type system, and we put it in in the database depending on the plugin. So that's, I think, like in really high level. So it's like it's gRPC, it's which makes it pluggable, and then a lot of things basically around the CloudQuery type system, which makes you like makes the whole thing work. So you transform it to one type system, and then once it's transformed to something that we know what it is, then we can transform it in a generic way to any other destination.
So then looking forward, I assume you're going to be doing at least two things. Number one, support more sources. Number two, support more destinations. But there I may even see a limit. I feel like it's going to converge quickly into probably like a handful of destinations,
Yeah, I think destinations are much less. We already support like more than 10, but yeah, destinations is like on order of magnitude smaller than the number of source plugins and APIs.
Yeah, and I expect that people will gravitate towards S3 or Google Cloud Storage
on data lakes.
Yeah.
On data lakes.
Yeah, fascinating. What else should we know about CloudQuery that's interesting that we haven't covered so far?
Yeah, I think we covered quite in good detail, like the high level architecture of CloudQuery and how to run it. And yeah, I think that's pretty much it. If you go in our docs, then you can also like there is like everything in our docs is open source, and you can basically just try it out locally. And also like we have a Discord as well, where if you have any questions or you are stuck, we are happy to help.
Yeah, I think it's fascinating to see how we're seeing things come full circle. The modern data stack or cloud warehouses started 10 years ago, the renaissance of SQL, bringing software engineering principles to working with data. And now we're bringing it back, the whole modern data stack back to infrastructure. And now we need to teach infrastructure engineers to work with these principles. I think it's fascinating.
It is full circle, definitely. Like it's SQL is a bit like JavaScript. You hate it, but I mean, you're stuck with it.
Yeah. Never bet against SQL. Never bet against SQL.
Exactly. So, like, at the end of the day, the fundamental problem is querying data, and it is what it is. So use SQL, or like even if it will be something else, it will be still querying data. So like the fundamental problem doesn't really go away of querying data.
Yeah. I feel like we have enough. There's even enough stuff we can talk about in a future episode about how this compares working with some of the existing monitoring and logging tools. But I think we covered plenty of ground today. So to reach you, people can go to cloudquery.io, see the docs. There's a link to your Discord server. You're pretty easy to find in your Discord server or on LinkedIn. And I think this was an exciting episode. Looking forward to the show notes and publishing it. I think we'll see a lot of interest here in CloudQuery. Yevgeny, thank you so much. All the best. And I would say this concludes this episode, and we'll check back in a few months.
Yeah, thank you very much, Lars. I appreciate you having me on the show. It was great talking to you.
Thank you, Yevgeny. Thank you, Yevgeny.
Right.
3, 2, 1, stop. Okay. That was awesome, dude. I think hold on, I'm trying where my mouse is here. Here's my mouse. I think we can stop it now. Hold on. Oh my God. Hold on. What is going on with my browser here? There we go. Okay. So I can stop. Okay, boom, I'm stopped.